It's fine now.
Yeah.
Okay. Okay, thank you very much for that. Now, let me just remind you about the properties of expectations and properties of variance. I believe that you did this maybe in level 2 or level 1, I'm not sure, but what I know is that you have done this, the properties of expectations. Now, the expected value of y bar 1 minus y bar 2 is equal to what? If you still recall, it's equal to the expected value of what? Y bar 1 minus expected value of y bar 2, isn't it? According to the properties of expectations. Now, if y bar 1, okay, is an unbiased estimator of mu y1, then what? Then the expected value of y bar 1 is equal to what? To mu y1. Okay? And again, and then again, if y bar 2 is an unbiased estimator of mu y2, then what? The expected value of y bar 2 is equal to mu y2. So, sorry for that. So therefore, the expected value y bar 1 minus y bar 2 can also be written as what? Expected value, like what we did before. Okay. Let me just rewrite this one so that you can follow the logic. Y bar 2. So this can also be equal to what? Mu y1 minus mu y2. Okay. That's about the expected value. Now, for the variance, the var of y bar 1, y bar 2 is equal to what? You can tell me. The variance of y bar 1 minus y bar 2 is equivalent to?
The var of y bar 1 plus the var of y bar 2.
Var of y bar 1 plus the var of y bar 2. Is that correct? That's fine. Any suggestion?
Curve.
Minus 2 curve, yes. Minus 2 curve. Y bar 1, y bar 2. Remember, we are not sure whether y bar 1 and y bar 2 are independent, isn't it? So that is why we're having this expression. Var of y bar 1 minus y bar 2 is equal to the var of y bar 1 plus var of y bar 2 minus 2 curve of y bar 1, y bar 2. However, if y bar 1 and y bar 2 are independent, then what? The var of y bar 1 minus y bar 2 will be equivalent to the var of y bar 1 plus var of y bar 2. Okay, if y bar 1 and y bar 2 are independent, so the curve of y bar 1, y bar 2 is equivalent to 0. Then at the end of the day, we are having var of y bar 1 minus y bar 2, which is equivalent to var of y bar 1 plus var of y bar 2. Okay. Now, this can also be equivalent to the var of y bar 1 can also be equivalent to sigma squared 1 over n1 plus sigma squared 2 over n2. Okay. Okay. Similarly, the estimated var of y bar 1 minus y bar 2 can be written as the estimated var of y bar 1, y bar 2 can also be written as the estimated var of y bar 1 plus the estimated var of y bar 2. Again, y bar 1 and y bar 2 are independent. So, which is equal to what? Which is equal to what? So, which is equal to as let me just write it down there so that we can have a space. Let me just write it here, which is equal to s1 squared over n1 plus s2 squared over n2. S1 squared is a simple variance, isn't it? So that's it. So those are the estimates for the mean and variances. Okay. So now let's quickly go to the example and see how can we apply this. Is there any question before we go to the example? Is there any question before we go to example? So let's quickly go to example 3.12 on lecture notes. It's page what? 21. Example 3.12. Yes. That is page 21 in a lecture notes. Okay. So let me just give you just few minutes just to analyze that example, then that we can start doing it. Just giving you just a minute to read on that example. Then after that, we are going to try to solve it. Just giving you a minute to look at it. Okay, I hope now you're done. So let's just quickly try to go through it. Now we are considering table 3.5 there, down there. Okay, consider table 3.5. That shows that the data from a random sample of 35 lakes. It shows the data from a random sample of 35 lakes. In other words, we've got lake types here. Lake types. Okay. There is type 1, type 2, and type 3. Okay. So there is type 1, 2, and 3. It's lake of type 1, type 2, and type 3. So lake of type 1, it shows the balance between decaying vegetation and living organisms. So lake of type 1 represent balanced between decaying vegetation and living, just use this one, and living organism. Those are the given information, okay, about lake of type 1. So lake of type 2 to represent the high decay rate, okay, and little oxygen. Those are the information that we got from that expression. Okay. The third one, lake of type 3, shows the balance between I think this is between lakes of type 1, type 1 and 2. So now, the information or the results are summarized on page 22. If we go to page 22, there is a table that summarizes the results there. So let's consider that table that summarizes the results. Of course, it's very important. We are going to refer to that table. Let me just create a big space now. Okay. I want a big space for the table. Okay. It's a summary, statistics or summary results. Okay. So we have types of lakes. Okay, which is type 1, 2, and 3. And we've got the what? The sample sizes. They call them counts. Those are the sample sizes. N. And then what? The mean. Those are the sample mean, y bar. Then let's consider the median now. It's not necessary. So the standard deviation, let's put it as, okay. Okay, the sample size of type 1 is 4. Type 2, 15, and then the last one is 16. Sample mean of type 1 is 0.22. Type 2 0.74. Type 3 0.5. The standard deviation of type 1 0.103. Type 2 0.583. Type 3 0.272. Those are the information that are given. Now the question says, just copy. Question says what? Is there on page 22, number A, is there any sufficient evidence to conclude that the mean level of leaks of type 1 differs from that of type 2? That is the question. Is there any sufficient evidence to conclude that the mean level of leaks of type 1 differs from that one of type 2? So here we just want to compare the estimated mean. Okay, so we just want to compare what? The estimated mean estimated mean with the bound. With the bound in the error of estimation. Okay, in other words, we just want to do what? To find the interval estimates of difference in means. Let's say we just want to find what? Interval estimates of difference in what? In means. Okay. How do you do that? How do you find those interval estimates? Okay, let me just go down a bit. So you use y bar minus y bar 1 is y bar 2 plus or minus 2 times the square root of what? The estimated var of y bar 1 plus the estimated var of y bar 2. Okay, and remember this part, this one, this one represent a bound, if you still recall. Here, this one is the difference in means. Okay, so now, so this will be equivalent to y bar 1 minus y bar 2 plus or minus 2 times the square root. The estimated variance of the estimated mean is the same as what? S1 squared over N1 plus S2 squared over N2. Okay. Which is equivalent to. So what is the estimated mean of legs of type 1? What is the estimated mean there?
0.22.
So it's 0.22 minus the estimated mean for leg 2, which is what? 0.74.
Yeah.
74. Okay. Then plus or minus 2 times the square root of. What is the variance, the sample variance of the legs of type 1? The variance?
0.103.
That is a standard deviation. Variance is what?
0.0103 squared.
0.103 squared.
Ish.
That is the variance. Then you divide by simple variance of leg 1. Simple size, sorry.
4.
Okay. Then plus the variance of type 2. 0.583 squared. Then you divide by what? By 15. Okay. Remember, on the table there, summarized table, they gave us the standard deviation. And here we are calculating what? The variance. We have to substitute the variance. Okay. So that is why we just square 0.103 because it was a standard deviation. Then you have to just square it to get the variance. Yes.
Why are we not using that formula of the variance, the one where we multiply with n minus n and n in the numerator, capital N?
Oh, here we don't have the population. They didn't get. Did they give us any population there? Did they?
No.
So there's no information about the population. So there's no need to use that one. You have to use this one as it is.
Okay.
Then those who are having calculators, may you please calculate this one for us? Just want to see the answer. So it's an interval, isn't it? So we're expecting to see something like this.
Negative 0.83.
Minus 0.83.
382.
So 382. 0.8.
388.
Oh, so it's 84, isn't it?
Yeah.
Okay. The other one? There are two, remember.
Negative 0.201.
Okay, negative 0.2. Let's say 20. Now the question is 0 included there?
No.
0 is not included. So since 0 is not included in the interval, so type 1 and type 2 legs are significantly different. Okay, let me just write it down. In conclusion, since 0 is not included in the interval. So type 1 type 1 and type 2 lakes are significantly different. Okay, yeah, because 0 is not included, so type 1 and type 2 lakes are significantly different. Now, the difference could be anywhere between, so the difference can be anywhere between these two values, between minus 0,84 and minus 0,20. So there is a difference. I think it's clear. So if you check from the lecture notes there are two questions, which is A and B. Then we managed to answer number A. Can you please answer number B? So I will write it down for those who don't have it. Number B says, is there significant or is there any sufficient evidence to conclude that the mean level for lakes of type 2 differs from that for lakes of type 3? That's number B. Let me write it down. Is there any sufficient evidence to conclude that the mean level for,
Sir,
yes,
what if on the first question, what if I said 0.74 minus 0.22?
0 point from where?
The first question.
Or up there, let me see. You mean here? Instead of writing this one, you write that one. You start, in other words, you start with y bar 2 minus y bar 1. So what we are saying?
Yes. Yes.
No, we have to start with y bar 1. You have to start with y bar 1. I don't know. Can you go and check and whether you can see any difference? But normally you have to start with y bar 1 minus y bar 2. Have you calculated and find something? But I don't know whether it's going to have any significant difference. But you can just go and check. Levels lakes of type 2 differs from that of thread 3. So please try this one. Or you'll do it later and we go to other stuff. But just do it now, and see the results. Our time is almost there. Are you winning?
Yes, we are done, sir.
Okay, I'm waiting for the answers. Answers are what?
It's negative 0.09
And what?
and 0.57.
Yes, that's correct. So what can you conclude? Is there any difference?
Yes,
Why?
0 is included.
If 0 is included, is there any difference?
There is no difference.
There is no difference.
There's no
There's
difference
no
because 0
difference.
is. Yeah. Thank you very
It's
much. Since 0 is
insignificant.
included. Yeah, so there is no difference. Okay. Within these 3 minutes, let me just show you how to compare the proportions. Then the example will do it on our next class. Any question? Any question before we move there to another topic? None. Okay. So comparing, like I said, we are comparing the estimates. We started by comparing means. Now we are going to compare the proportions. Comparing proportions. Okay. Now the expected value P1 hat minus P2 hat is equal to P1 minus P2. Okay. And the var P1 hat plus P2 hat. Sorry. P2 hat is equal to what? The var of P1 hat plus the var of P2 hat minus, okay, 2 curve of P1 hat, P2 hat, okay. And you know that if they are independent, so the var of P1 hat minus P2 hat is equal to var of P1 hat plus var of P2 hat. So now this, it has been proven. In our case, we just want to apply it. It has been proven that var of this one is going to be P1 Q1 over N, okay, plus, sorry, P1 Q1. Please mute your mic. So P2 Q2 over N plus P plus 2P1 P2 over N. So that it means that the var of P1 hat minus P2 hat is equivalent to P1 Q1 over N plus P2 Q2 over N plus 2 P1 P2 over N. It has been proven. But in a case we are not interested in proving it, we just want to apply it. So this one can also be equivalent to what? P1, 1 minus P1 divided by N, isn't it? Plus P2, 1 minus P2 divided by what? By N. Plus 2 P1 P2 over N. The same thing. Okay? Likewise, if you are considering the estimated variance, you are going to have what? The estimated variance of what? P1 hat minus P2 hat, which is equal to estimated var of P1 hat plus var of P2 hat minus 2 curve of P1 hat, P2 hat, which is equal to what? P1 hat, let's say 1 minus P1 hat over N plus P2 hat, 1 minus P2 hat over N plus 2 P1 hat P2 hat over N. So those are things that I wanted to introduce. Then later we are going to apply the example. We're going to consider the example so that we can apply these things. Our time is up. Thank you very much. Any question?
Sir,
Yes.
I was asking if you could send the answer sheet, like the formula sheet, like the formula sheet. I mean formula sheet. I want to see like what